Distinguished colleagues, distinguished guests, I would like to declare the meeting of the Dissertation Council open to review the dissertation submitted by Elizaveta Kalinina under the title Applying Algebraic Methods for the Complex System Analysis in the subject field 051301, System Analysis, Information Control and Processing in Applied Mathematics and Processes of Control. According to a decree at St. Petersburg State University as of May 23rd, 2018, number 4808/1, me, Evgeny Verumey, Doctor of Physical and Mathematical Sciences Professor, was appointed to chair this meeting. I would like to introduce my colleagues: Nikolai Kuznetsov, Doctor of Physical and Mathematical Sciences, Professor, Applied Cybernetics Department; Vladimir Kharitonov, Doctor of Physics and Maths, Professor, Theory of Control Department; Vladimir Gert, Doctor of Physics and Maths, Integrated Institute of Nuclear Research; Michael Gnatich, Doctor of Physics and Mathematics, Institute of Experimental Physics, Slovak Academy of Sciences. We've got Professor Kharitonov in a remote mode. As of the federal law, as of 23rd of August 1996, on research and state policy in research, St. Petersburg State University has been granted an exceptional right to award academic degrees with a relevant decree issued at St. Petersburg State University on September 1, 2016, number 6821/1, hereinafter referred to as decree. According to the decree, the Dissertation Council is considered legitimate unless no less than 2/3 of its initial composition is there, but no less than 4 people. We've got all the 5 members of the Dissertation Council, including 1 member in a remote mode, Vladimir Kharitonov, Doctor of Physics and Mathematics, Theory of Control Department, and we have audio-visual contact with him. Thus, the quorum is there. Colleagues, I would like to suggest the following rules of procedure. On the whole, the meeting should not last over 2 hours. First is a short report submitted by the chair on the documents presented by the defendant according to the requirements, and Q&A session to follow. 5 minutes maximum, a short report delivered by the defendant on the key findings of the research, 20 minutes maximum, questions to the defendant, 2 minutes per question, which is followed by members of the Dissertation Council taking turns in asking questions, 2 minutes per question. Then members of the Dissertation Board present their reviews. Then the chair presents his reviews, to be followed by an open discussion with all the members of the audience participating in the discussion, asking questions, 5 minutes per question. Everyone wishing to take the floor, please register in advance in a registration list and introduce yourself before having the floor, to be followed by the defendant's replies and the research supervisor's address. A 5-minute discussion on the open voting on whether pass or fail. The discussion is not broadcasted online. This is followed by an open vote by name with the chair of the Dissertation Council counting the votes, and ultimately the decision-making whether pass or fail. Wrapping up is the defendant's final address, 5 minutes maximum. Before we start implementing the agenda, I would like to urge everyone to switch off their mobile devices. Thank you for compliance. May I also inform you that we've got audio and video recording, which is broadcasted live at St. Petersburg State University website. Simultaneous interpretation from Russian into English and vice versa is there. I would like now to proceed to the first point on the agenda, which is the chairman's brief report. The dissertation by Elizaveta Kalinina, submitted in conformity with the Doctor of Sciences in 051301, System Analysis, Information Control and Processing, under the title Applying Algebraic Methods for the Complex System Analysis, was admitted for defense as of a relevant decree as of May 23, 2018, number 4808/1, as referred. The composition of the dissertation board is well known. The defendant has submitted the following documents: an application form addressed to Rector Kropachev, submitted on April 3, 2018, on submitting the dissertation. A review by the research supervisor Alexei Uteshev, Doctor of Physics and Maths. The list of publications, 20 papers overall, including 12 in fellow-reviewed journals. The diploma of a candidate of sciences in physics and mathematics as of July 12, 1996. A dissertation in Russian and English in soft and hard copy as a manuscript, drafted according to GOST requirements and printed on a regular printer, as GOST stipulates. I'd like to note that all the above-mentioned documents are in conformity with paragraph 12, section 3 on academic degrees awarding procedure in St. Petersburg State University, appendix number 1 to the decree. Elizaveta, now the floor is yours. You have 20 minutes, please. Distinguished members of the dissertation board, distinguished colleagues, I would like to suggest the dissertation submitted in compliance with the Doctor of Sciences requirements under the title Algebraic Methods for the Complex Systems Analysis.
Professor Uteshev is the supervisor of this dissertation. Complex systems is a system consisting of many interrelated components. Currently, more than 50 research centers in various countries are engaged in the theory of complex systems. Such systems arise in various fields of human activity and in various fields of science, in information science, biology, sociology, economics, physics, and others. In most cases, the behavior of complex systems depends on its parameters. The dissertation most focus is on the study of dynamic systems, and also highlight some systems with shifts. In most cases, the behavior of a complex system depends on its parameters. Therefore, it is of fundamental importance to investigate the dynamics of such a system when the parameters entering change, including finding their bifurcation values. In particular, the tasks of robust management and sustainability are important tasks. In the thesis, an algebraic approach is proposed to analyze the behavior of complex systems. Mathematical modeling and structural parametric and thin synthesis are used. And it was possible to solve and make substantial progress in a number of problems in the theory of complex systems. In many cases, well, computational capacities now make it possible, and computational algebra and Mathematica and other systems are developing. Well, let's look at the tasks that have been solved in the dissertation, or progress has been made. And, as we said, dynamic systems are part of the complex systems, and the most important problem is to study the characteristics of solutions of such systems, depending on their parameters. Well, bifurcation parameters are very important, and also stability characteristics that are important for the management of movement of different objects. Such tasks are reduced to the matrix study of the linear, and that's when polynomial is known, and therefore we have to solve the system of polynomial equations. And however, the calculations of the characteristic polynomial of the matrix is often a computationally expensive task. Therefore, the problem of localizing the spectrum of the matrix arises without computing its characteristic polynomial, in the especially the problems with multiple numbers of the matrix eigenvalues. Also, the theory of graphs is applicable, and that helps to simplify the description of the complex system, and also to analyze some of the solutions. An algebraic approach is applicable to the theory of graphs, and some of the issues are considered in this station. In the study of biological systems with ion channels of cells, with the help of computation, numerical methods are applied. In this solution, we need to have very fast numerical methods to solve these systems tasks. And the aim of the work is the development of constructive algebraic algorithms that allow to advance in the solutions of the problems considered, and also the applications of theoretical and practical problems. And you can see some methods: a system of analysis, parametric analysis and thesis, methods of classical higher algebra, and method of system analysis, method of graphs. In the first chapter, the dissertation deals with the localization of the roots of a real family of polynomials, and the problem is important because we study movement of different objects, management of this movement, and to solve these tasks, problems of robust stability in controlling the movement of various objects arises. And also we have well-known algorithms are applied that are used in systems of symbolic calculation such as Maple, MATLAB, and Mathematica. However, the available algorithm are computationally expensive, and they're based on Huberger algorithms. And for this, we don't have calculations of the duration of their work, and for the systems of general type. So you have the results for a family of real polynomials with coefficient polynomially dependent on parameters that vary within a multidimensional real parallelepiped. The criterion for the absence of real roots is proved. A criteria for the presence of all the roots of the polynomials of the family in some algebraic domain D of the complex plane. Constructive algorithms are developed for testing the stability and destability of all polynomials of the family. Numerical examples illustrating the work of all the proposed algorithms are given in this paper. For example, real cases presented in which the control of the movement of a real bus, Daimler-Benz bus, is considered. As a result of the proposed algorithms, polynomials are calculated whose roots are the required values. However, calculations that are accurate are computationally costly. Polynomials of high degrees are obtained. Thus, in the above example, of the 8th power in Z, the degree of the resultant in V is 20, and the degree of the final equation is 145. As I said, the second chapter of the thesis, the questions of localizations of eigenvalues of the values of the matrix are considered, and I already mentioned that that in many sciences these calculations and algorithms are important, and we have quantum mechanics, and the fields of science. Many results obtained for small perturbations of matrix elements. The Holder conditioning number is used to estimate the change in its multiple eigenvalues. For arbitrary perturbations, the results are presented in the works of Jalbring, Esqual, Michaels, etc. Nevertheless, new effective algorithms are needed, since the available ones have insufficient accuracy, so the problems of constructing the Jordan number form remain unresolved in the case when the parametric matrix has multiple eigenvalues. The following results are obtained. Algorithms for finding common eigenvalues of a set of matrices are created. Finding the maximal order of the Jordan cell and the eigenvalues corresponding to the Jordan cells of maximal order. Algorithms for finding parameter values for which a matrix with elements linearly dependent on a parameter has multiple eigenvalues. In the third chapter of the thesis, problems related to the application of algebraic methods in graph theory are considered. With the help of graphs, multi-agent systems, switching systems, and the problems modeled by differential equations on graphs are investigated. Matrix algorithms as presented to recognize the edge graph. The problem has been studied, but it still remains relevant. Several algorithms are known to solve this problem. A new matrix algorithm for recognizing the edge graph and constructing its root graph is presented in the thesis. you can see here the problem of where edge graph is used as the problem of protein docking. There are two three-dimensional molecules with atomic resolution, and the question is, do a protein molecule and a ligand molecule bind to each other, and if they're connected, what does the complex look like? The problem comes down to the task of finding the maximum clique in a graph whose vertices correspond to pairs of suitable points, receptors, of the protein and ligand, and the edges are carried out in the case of equality of distances. And also the problems of finding the general chemical, chemical structure of two substances and routing along fixed paths. And so these two, all these problems are NP complete in the general case. However, if the existing graph is an edge graph, then they're polynomial in time. In the fourth chapter of the thesis, we consider a new algorithm of solving the Cauchy problem for a system of ordinary differential equations with the least total error. As I said, and the problem is very important because biological systems in some cases are studied with the use of Cauchy's problem in real time, and we need accurate methods of real-time integration, and the explicit Euler method as well as the Euler and exponential methods are used in the modeling and simulation of biological systems. For example, in the study of ion channels of cell membranes. But early estimates of the accuracy of these methods were obtained, but routing errors were not taken into account. There remains a need for high precision rapid methods. In particular, they are necessary for experiments using a computer. And the thesis, an effective high precision algorithm for finding the optimal step of the Euler method is developed, which makes it possible to construct a solution of the Cauchy problem for a system of ordinary differential equations with the least total error. You can see the operation of the algorithm is illustrated in numerical examples. We consider rigid systems as well as a system of differential equations with discontinuous right-hand sides. You see graphs here. The variables depending on the time are also cited. You see the time, the least steps and the largest steps, and the error estimate of the step. For these systems, solutions were received. In comparison with well-known methods, higher speed is obtained. We have the basic results that are presented for defense, an analytical algorithm for stating the influence of parameters on the dynamics of complex systems, an algorithm for testing robust stability and the d-stability of a family of real polynomials, and the algorithm for finding the common eigenvalues of a set of matrices developed for the analysis of multi-component systems, and highly effective algorithm for Cauchy system applicable for the study of complex systems. Yes. Thank you very much.
Okay. I think we should follow the rules of the procedure, and I have to address my question to the members of the audience. Do any one of those present have questions to the defendant? No questions. No external reviews have been submitted. Therefore, we can proceed to declaring the reviews submitted by members of the dissertation board. Elizaveta, you may take your seat. Distinguished colleagues, well, I think it's up to you on how to deliver your review. I think there is no reason in reading out your review, but for the last passage, the conclusion, I mean. But I really urge you to speak freely, in short, on your reviews. So let's follow as the list says. Nikolai Kuznetsov, Doctor of Physics and Mathematics, Professor Applied Cybernetics in Petersburg State University. Professor Kuznetsov, you have the floor. Well, my review is published on the website. It includes 4 pages. I'm not going to read out the entire text. I just would like to note the relevance of this dissertation, especially the results of the first chapter that looks into the results by Vishnegradsky and the the Rouse-Gorbitz mathematical methods then were developed by Vladimir Kharitonov. These results are truly impressive. And this is there in the review. In conclusion, my review says that the dissertation by Elizaveta Kalinina under the title Applying Algebraic Methods for the Complex Systems Analysis is in conformity with the relevant decree number 6828/1 on academic degrees awarding procedure in St. Petersburg State University, whereas the defendant, Elizaveta Kalinina, deserves to be awarded with the inspired academic degree of Doctor of Physics and Mathematics in 051301 System Analysis, Information Control and Processing in Applied Mathematics and Processes of Control, signed by Professor Doctor of Physics and Mathematics Nikolai Kuznetsov, June 28, 2018. Do you have any recommendations? Well, my recommendations are mentioned in my review, but they do not invalidate the excellent impression. Well, I read them out. There are some syntactic mistakes, there are some misprints. For example, page 57, there is an extra question mark. Page 123, the cases are discordant. So my question is whether the asynthetic metric search is more efficient than the other options. And there is one more recommendations. In chapter 2, Elizaveta says that the suggested metrics algorithm can be integrated on the basis of the matrix polynomial. Could you please describe how that occurs? These recommendations do not invalidate the excellent impression of this research. The results obtained are indeed a contribution in the development of complex algebraic systems. The results are very well evidence-based. The suggested algorithms are more efficient than the well-known methods, which is truly important. Elizaveta, Would you feel more comfortable to take all of the recommendations at once and to give your replies at the very end? Okay. The next speaker is Vladimir Gert, Doctor of Physics and Mathematics at the University of Nuclear Research, Institute of Nuclear Research. Well, relevance. I would like to say a couple of words about the relevance of the dissertation. Well, some words have already been said about that. But the objectives of the dissertation, or rather would split in two types that are now being intensively investigated in Europe. There is a biochemical project in Europe going on, looking into biochemical systems, and all that has medical practicality. So depending on the parameter, we calculate the equation. So the maximum list of parameters is 16. I don't know exactly, but this is an exponent. I believe that this is what makes this research so complex. And the objective was the bifurcation analysis. This is what I would like to highlight. So the complexity of the objective in this project, as well as in this dissertation, is that nothing is known in the velocity of a reaction and the response. I believe that the defendant could have implemented this method to deliver on other objectives. It's no doubt that the dissertation is highly relevant. I'm not going to read my review out, but this is what I would like to underscore. The computerized algebra system, it has very well implemented algorithms, but those compel to do so many calculations that it would take just unreasonable time. Let's look at the Weiss-Grobner system. Over the last years, the 10-15 years, algebra has advanced significantly in its methods. But the biochemical reactions, there's no chance to do this, to implement this type of methods. Well, in some individual cases, we could obtain the quantum, but there's no other way. So all the results are very well evidence-based, experimentally, including the last section in the graph theory, the discrete mathematics, implementing the most developed methods in discrete mathematics, in algebraic analysis, algorithm analysis. So this is a huge step forward in recognizing the edge coverings of graphs. Yes, indeed. If a graph is the one which is edge covering, then this is it. And lastly, ultimately, the last section, I also would like to outline it. The computerized integration and the step size optimization, those are highly relevant results. I have never seen anything which would be the parallel. So this is indeed an unparalleled research. Normally, this is done experimentally, and hopefully you have what to compare your results with. But here we see optimization, the step size optimization, which means that we select the most optimum size of the step. This is of ultimate value. So I'm not going to go on like that. I would like to highlight that the findings are evidence-based and highly innovative. However, I would like to highlight my point of criticism. They are there, as in those would be in any work done. There is something to criticize in everything. I've got 4 points for criticism. Chapter 4, the high-precision method to solve the Kashi task. The optimum integration step. But the complexity is that it depends on the right part of the system, on the structure of the step. So if in practice we see minor variations in the right parts, so how would the step behave itself? So this is something beyond the discussion. So this is what I would like to ask. If you have some spontaneous task, some chaotic task, this is not what you investigate in that cases. The second thing, when you calculate the matrix trace, could you please describe how would you implement the parent-site lemma, page 116? Well, some abbreviations and some signs, the Latin E, probably this is the influence of the Russian, and the E letter also indicates a different matrix of the main diagonal. Well, this a little bit deviates you from the idea when reading. But those are normal things when you're writing such a solid work. So the same letter indicates the sense for the matrix and for the vector. Sometimes this impedes understanding, but the context is clear. However, these points of criticism do not invalidate the dissertation and do not spoil the overall highly positive impression. My conclusion is that the dissertation submitted by Elizaveta Kalinina under the title Applying Algebraic Methods for the Complex Systems Analysis is in conformity with the requirements stipulated by the decree as of September 1, 2016 on academic degrees awarding procedure in St. Petersburg State University. Whereas the defendant Kalinina Elizaveta deserves to be awarded the aspired academic degree of Doctor of Physics and Mathematics in specialty field 05-1301 System Analysis, Information Control and Processing in Applied Mathematics and Processes of Control. Thank you, Vladimir. Next speaker is Michael Gnatic, Doctor of Physics and Mathematics, Institute of Experimental Physics, Slovak Academy of Sciences. First and foremost, I would like to highlight that complex systems analysis is a challenge always. Those tasks are fit for engineers, for physicists, and theoreticians, as well as mathematicians. This is clear that the entire world is a complex system, a physical system, ecosystem, biological system, social system, economical system, markets, so on and so forth. So in this respect, the dissertation by Elizaveta Kalinina is devoted to develop efficient algebraic methods in how to observe and investigate into the behavior of complex systems. These methods are highly relevant for robot control and sustainability, the challenges that arise in nonlinear dynamic systems. And in my review, I explain why these objectives are so relevant. The relevance overall of the dissertation is undoubtedly thanks to the fact that the developed methods can be implemented on a broader scope in a variety of systems. What makes this dissertation innovative is the 5 aspects. And I'm not going to focus on that because this has been presented by the defendant herself in her speech. I would like to highlight that the dissertation benefits from the fact that it has cases in point with digits to demonstrate how algorithms work. The results presented are innovative, evidence-based, and very well justified by way of algebraic devices and the graph theory. The results are in conformity with the numerical experiments results as well as the results obtained by other researchers. I would like to focus on the practicality. These results allow us to save up time in calculation and to do the control system synthesis. The evidence-based nature of the results is proved by the published papers. 20 papers, including 12 in fellow-reviewed international and Russian journals, recommended by the Higher Attestation Commission of the Russian Federations, as well as the opportunity to discuss the results at 10 Russian international conferences. Once again, as my colleague said, I do have some critical points to focus on, and I would like to read them out. The first one is the fact that the Goldner numbers are calculated for each matrix. In Chapter 2, you suggest to find out the maximum order of Jordan algorithm. Therefore, for multiple eigenvalues, the assessment of eigenvalues will be less precise. Second, in Chapter 3, you have the algorithm of edge-covering recognition graph. I would like to see the comparison between the results across various algorithms. Third, there is no definite conclusion in the polynomial root, Chapter 1. And fourth is that the text is well drafted, but there are some stylistic discordances. Not all illustrations have signatures. For example, page 129, 130. You also note that the numbering of the illustrations is different. In Chapter 4 is different from the enumeration in other chapters. I would like to highlight that, however, that these points of criticism do not invalidate your dissertation. It is a well-rounded research that yields innovative results and observations on the behavior of complex systems depending on the parameters. The findings of the dissertation are indeed an endeavor and a breakthrough. Therefore, the dissertation submitted by Elizaveta Kalinina under the title Applying Algebraic Methods for the Complex Systems Analysis is in conformity with the crucial requirements stipulated in the decree number 6821/8 on academic degrees awarding procedure in St. Petersburg State University, whereas Elizaveta Kalinina deserves to be awarded the aspired academic degree in Doctor of Physics and Mathematics in the specialty field 051301, System Analysis, Information Control and Processing in Applied Mathematics and Processes of Control. Well, this is it for my part. Thank you. I would like to give the floor to Professor Harry Tornov, Doctor of Physics and Mathematics, Professor of Theory of Controls in Petersburg State University.
Thank you very much. First, I would like to thank the organizers of the defense for inviting me and having this opportunity to be in the remote mode. And I would like to explain why. Unfortunately, I have to teach in Peterhof today, and therefore it's difficult for me to personally get from Peterhof to the city. And I would like to focus on the first results in more detail and the criterion of robust stability, where the polynomial characteristics depend on the parameters. Well, the coefficients are linear functions of parameters. The effectiveness of the method is based on the exclusion of zero, is that for such families it's very not difficult to construct sets when nonlinear dependence is involved. There have been attempts to apply this exclusion of zero method to these sets, to families, and Professor Kerman's monograph on Bhattacharya monographs have been cited, but the verifiability of the results are in doubt. So Elizaveta proposed a very novel approach that doesn't involve the exclusion of zero method, but by the successive exclusion of variables. And with this algorithm, then the coefficients polynomial functions of parameters have been obtained, and the results of this work derives from the fact that the end polynomial, which is in fact the one that determines the robustness or stability, is a polynomial of high degree and high power, and the degree is 145, and of the fifth, the system of fifth order, and the problems there is not very maybe negligible, but creates non-negligible problems. The advances in computational techniques are so high that in the future these problems will be solved, and these algorithms will be used in calculating the robust stability. And another issue that some analysis methods have been proposed in the real numbers in matrices, and especially the matrices and the Sylvester operator, and there have been method proposed to find eigenvalues, and although I have some doubts regarding the complexity of this algorithm, I would like Elizaveta Alexandra to comment on this, because eigenvalues of both matrices can be calculated in different ways, but the evaluation of the relative complexity is lacking. Assessment of such considerable complexity is lacking in the dissertation. And the last comment has to do with the last fourth chapter, both in the presentation and in the work. You consider the error and the assessment of error are considered in the same ways. They're like synonyms, but they are not. because the method of choosing a dynamic choice of step, assessment of error can be good and can be bad, but the dynamic way of choosing a step leads to an equation that is too complex. We have very good heuristic algorithms of choosing this step, and the algorithm, the fact that this algorithm works is illustrated by numerical examples, and I think this method will be polished in the future. And in addition to the comments that I made previously, I was a bit disappointed by the formatting or the wording of the text. And the same matrix has different measuring, Kn for Kk and other. Well, unfortunately, the measurements are different at the beginning, in the middle, and the end of the calculations. And in mathematics, there are some auxiliary statements. They're called lemmas, and the main statements are called theorems. And there are no lemmas in the work, even not so considerable results are written down as theorems. But judging the work as a whole, I think that the dissertation submitted has new theoretical statements, and that it makes a contribution to the science in the same field, and it is in conformity with the requirements of St. Petersburg State University on awarding the sought degree, and the defendant, Kalinina Elizaveta, is entitled to be awarded the degree of Doctor of Sciences in Systemic Analysis of Control and Information Treatment, and I signed and dated my review. Thank you very much. I would like to voice my comments regarding to this work. Elizaveta Alexandrova's dissertation focuses on computational methods, algebraic methods, and the study of complex methods. Well, algebraic approach is natural when such systems are either totally linear or have linear components, or a linear approach is used, and from the very beginning of the development of ideology to treating this system, algebra was involved in the early attempts too. The only problem is that when steps are too large and the complexity increase so much that numerical methods, the formula of Cardan is hardly used with high orders, and before we had high capacities of computational facilities, then researchers used very rough approaches to calculating the robustness, the parameter grids, and they tried to transform variations of the input parameters to the variation of the parameters of polynomial, characteristic polynomial. And so because of the lack of computational capacity, packets of mathematical methods are now developing with the rise of computational capacities. The packets of symbolic calculations based on MATLAB, computational algebra, they all make it possible to achieve accuracy, and using these possibilities was the motivation for this dissertation. As I understand, the results that have been obtained are very impressive, especially regarding robustness or localization of roots, which is very important with multi-agent system treatment, which is the research that is very popular, and the theory of graphs is one area where it is very useful, and the integration step treatment in chapter 4 is very important. Theory of Karitonov theorem is generalized well when the characteristic polynomial depends on the parameters, and of course there are some computational problems, but with the advent of more advances in computational technology, these issues will be resolved. I would like to add that to my colleague, when implement the backup, and then the problem with choosing a step will be there as well. But when the step changes dynamically, for example, on board a moving object, there are some computations. The system should be adaptable and should change the step automatically.
So there are lots of benefits in the dissertation. However, there are some drawbacks, and this is what I would like to note. Almost all of the results refer us to some ultimate algorithm. However, there is no clear-cut wording, and it would be great to have the block schemes of the relevant software that implements this algorithm, and some fragment of a code, either on MATLAB or on Cypress Pyrus. Page 31, when you identify the sum of Newton, the first sum is in conformity with the formula. It requires a separate formula. In chapter 2, it would be great to use a specific index for matrix vectoring. Overall, I believe that the dissertation is very well drafted. However, I have some recommendations for the style. It could have been styled better. I don't like the simulation being translated as simulation in Russian, whereas in Russian we have an imitation modeling. There are some mistakes, grammatical, syntactic mistakes. Page 30, page 32, 34, and others. Overall, I should note that this dissertation is a well-rounded research, which is of practical and theoretical value, whereas the results obtained are indeed innovative and evidence-based. So the efficiency of these methods is proved by relevant values. And this means that this dissertation is indeed a breakthrough in analysis and synthesis of complex dynamic systems, including the control systems. The list of papers published is quite exhaustive. There are those in Web of Science and the Corpus collection. All the findings are practical. And looking at the number of conferences where the key findings have been presented is indeed impressive. Therefore, the dissertation submitted by Elizaveta Kalinina under the title Applying Algebraic Methods for the Complex Systems Analysis is in conformity with the requirements stipulated in a relevant decree on academic degrees awarding procedure in St. Petersburg State University, whereas Elizaveta Kalinina deserves to be awarded the aspired academic degree in the specialty field 051301, System Analysis, Information Control and Processing in Applied Mathematics and Processes of Control. Doctor of Physics and Mathematics, Professor Very May. Elizaveta, now you have the floor. You have 15 minutes to reply to the commentaries. I would like to extend my gratitude to all the members of the Dissertation Board for their attention to my dissertation, for the questions, for reading my dissertation so meticulously. And I would like to provide my replies. I agree with all of them. I would like, however, to comment on the note on what Vladimir Viktorovich mentioned, Professor Haritonov, and Professor Gert. It may seem that calculating the eigenvalues without structuring the polynomies of matrices is easier, because then we have just a uniform system of linear equations. However, if we look more attentively, it's not that evident. And yes, indeed, it looks like that. And it is an impetus for further research. So this matrix is very scattered, and the elements within this matrix are not very well structured. So therefore, there are methods that allow us to calculate graphic polynomials. There is yet another news. There are other results that allow us to construct a discrete matrix. A similar approach for eigenvalues allows us to come up with an algorithm which is less consumptive and takes less time. I believe that this is a promise. So, because it may produce other results. The class matrix is indeed practical. However, it might be practical in resolving this particular objective and make it to simplify it, actually. As for Golder, yes, indeed, this is a perspective for future research if we look at how the matrix impacts the eigenvalues. As for other points of criticism, I take them. So are all members of the Dissertation Board satisfied with the reply? Yes, I'm satisfied. So am I. Thank you. Distinguished members, anyone present at the dissertation can take the floor, introducing themselves. Is anyone wishing to take the floor? Professor Bogdanov, please. Good afternoon. My name is Professor Bogdanov. Hello? Yeah, you hear me now? Great. Well, it's probably strange for me taking the floor in a dissertation about algebraic methods, but this is explained by the fact that I have been looking into these the methods to save up time, but the reason behind my speech is more profound. The available method that we have been researching into with Professor Knatic to push forward the applicability of these methods in the field of calculation, this results in non-trivial, huge matrices. Earlier, when I was a student and a postgraduate student, arriving at an integral was enough, but now we have a matrix and it's not enough. The end is not there. Therefore, we have to dig deeper. And therefore, this research is indeed a step forward, a significant step forward. I believe that we are witnessing the birth of a luminary expert. So I urge the members of the dissertation board to vote in favor of this dissertation. Elizaveta, you may comment. I would like to extend my gratitude to Alexander for his kind words. And yes, of course, I promise I'm going to make more endeavors in developing complex systems. It's not the end. Thank you. You may take your seat. According to the procedure, I would like now to give the floor to the research supervisor, Professor Uteshev. 3 minutes. I'm not going to praise the dissertation. I would like rather to say a couple of words about my student, Elizaveta. She has been my student since 2007. She's very laborious, stubborn, talented, and independent. Well, if you look at the publications, most of them are written independently, on her own, by her. She's the own author, the single author. Roughly 3/4 of the dissertation. Well, this is what I understand, and there's the remaining 25%. This is something a challenge for me to understand. Therefore, I should say that Elizaveta is an independent researcher. I always know that if I encounter some challenging task, so I always know who to address to. So I always ask Elizaveta to assist. Please, let's stop because we need the audio-visual connection via Skype. Do you hear me? Yes, okay, fine. So once I have to solve some complicated task, I know who to address. It is Elizaveta, and she would never give up. Even if she fails, she would move on unless she arrives at a solution. Well, as any person, she has a drawback. She has some drawbacks. And one of these drawbacks was evident in the point of criticism. She has difficulty in writing proper papers. So she knows, she's well informed about this issue, and she's trying to overcome herself, but this does not always result in a victory. So I recommend and I ask members of the dissertation board to support this dissertation. Thank you, Alexei. So according to the rules of the procedure, discussion is now to follow. Please switch off the broadcasting.
Dear ladies and gentlemen, dear members of the Session Council, our session, we're in session again, so broadcast should be switched on and to make sure that it works. Yes, everything is good? Yeah, okay. So they have a decisive moment and the Council's work. I'm putting forward for voting a verdict to confer or not confer a degree. I would like to say that no less than one half of the Dissertation Council and not fewer than 3 members should vote for the verdict, and the decision will be taken. So every member of the Dissertation Council can say yes, no, or infer. I vote for conferring the degree. Professor Gerd, your opinion? I am in favor of conferring the degree. And Mikhail Gennadych, what's your opinion? I am in favor of conferring the academic degree. Professor Kariton, I support the work that I think that we should vote yes. And my opinion, I also vote in favor. Thank you very much. So, on the basis of the count, just the members of the Dissertation Council, out of 5 members of the Dissertation Council present, 5 members voted for the decision, positive decision, and no abstentions, and no one voted against. So therefore, the degree of Doctor of Physical and Mathematical Sciences and the specialist degree 05.13.01 and Systemic Analysis, Management and Processing Information and Applied Mathematics and Control Process is taken. Elizaveta Alexandrovna, the floor is yours. Thank you very much for your comments, for your time in studying my dissertation, and thank you for the members of the dissertation for the fact that the defense has taken place and everyone present. Please, thank you very much for your attendance. The session is now closed. Thank you very much. The broadcast